Today I will be demonstrating a problem on the topic of combining functions. You are given f of x equals the square root of x plus 2, and g of x equals 14 over x. Part A asks you to write a formula for f composed g. In order to find the formula for f composed g, we simply examine the formula for f of x and input g of x into the x variable in the formula for f of x, and we are left with f composed g equals the square root of 14 over x plus 2. Similarly, when we are writing a formula for g composed of f, we examine g of x, input f of x into the x value of g of x, and are left with 14 over the square root of x plus 2. In order to find the domain of f composed g, as asked by part C of this problem, we simply set this equal to 0, and we can see that 14 over x has to be greater than or equal to negative 2, and that x cannot be equal to 0, as x is in the denominator. We see that 14x also has to be greater than or equal to negative 2x squared. We can manipulate 14 over x is greater than or equal to negative 2 to be 14x is greater than or equal to negative 2x squared with a little bit. This is the same thing as 2x squared plus 14x is greater than or equal to 0. We simply move it over, set it equal to 0. We solve this out here, factoring out a 2x. We are left with x has to be less than or equal to negative 7 and greater than 0. We can also write this as the domain must be equal to negative infinity to negative 7 and 0 to infinity. Part D now asks us to find the domain of g composed f. Examining g composed f, we must know that the denominator cannot be equal to 0, and thus x must be greater than or equal to negative 2. Thinking this through, we can see that x must be greater than negative 2, because a value of negative 2 for x here would give us the 0 that we do not want. So, knowing now that x must be greater than negative 2, we can now write the domain as a range from negative 2 to a positive infinity. We are now asked to determine the range of f composed g. I have written here, as a reminder, what f composed g was, and what the domain of f composed g was, as determined before. I have also written here for you the answer to the problem, so we know that the domain of f composed g was that x had to be greater than 0 and less than or equal to negative 7. And we know that the formula for the composite function was the square root of 14 over x plus 2. When we examine each part of the domain separately, we can see that for very large numbers, f composed g approaches the square root of 2, and that when x is negative 7, f composed g is 0. So therefore, we can see that the first part of the domain produces the values in the set where y is less than root 2 and greater than or equal to 0. Or we could write it as this: values from 0 to root 2. For the values of x that are near 0, the value of f composed g is large, and for the very large positive values of x, the value of f composed g is close to but will never equal the square root of 2, and therefore the portion of the domain x is greater than 0 produces the values in the set of y is greater than root 2, or written as this. Now, for part F, we're asked to find the range of g composed f. I have written here, once again, g composed f equals 14 over the square root of x plus 2, and the domain we found was ranges from x value ranges from -2 to positive infinity. For values of x that are close to -2, the value of g composed f is large, and for the large values of x, the value of g composed f approaches but never equals 0, and therefore the range of g composed f is y is greater than 0, or written as values from 0 to positive infinity. I hope that this video explained to you a calculus problem on combining functions.